So here's another example. What if we wanted to find the area above a z-score equal to 2.2? Now, I tell everybody, you know what? As simple as this is, draw out the z-score distribution. Okay, so draw a normal curve, and then shade in the area you're looking for. So put 2.2 around where you think it's going to be. It's only, it doesn't matter exactly. You just say, oh, I think 2.2 is around here. And then shade in what you're looking for. I'm looking for the area above 2.2, so I'm going to shade in this area. Now, when you look up 2.2 in the z-score table, what is it going to give you? It's going to give you this area. Remember, it gives you the area between 0 and the z-score you just looked up. So let's find out what this area equals. So I'm going to go back. I'm going to look up 2.2. So remember, you start here. And, oh good, there's the 2. There's more than one page to this table. I'm glad I included it here. All right, so here's the 2, and we want to go to 2.2. Oh, shoot. And I'm not going to be able to show you because this one only goes to 2.09. All right, well, 2.09, it's 48.17. That's the area, and we want to go even further out, right? Instead of 2.09, we want to go out to 2.2. So we know we're going to have an area bigger than this, okay? So what does it turn out to be? Well, if I provided enough information, a second page to the table, you would see that this area is 48.61. Okay, so again, going back, you see, we know it had to be bigger than this. This only went up to 2.09. So as we go out and get larger z-scores, what's happening to the area? Well, the area is growing as well, right? So 2.09, you would have this area. 2.2, you'd have a slightly larger area. Okay, so now we know that this area here is 48.61. Now we have to figure out what that area is. And probably the easiest way to do this is to just reason it out. This whole half is 50%. Remember, the distribution is symmetrical. So if this is 50%, and we know this is 48.61, then you just subtract them. Subtract this whole area. Okay, take this whole area, subtract out this area, and you're left with this. So we do 0.5000 minus 48.4861, or you could do it in decimal format. It doesn't matter. I mean percentage format. Here I have decimal. I could have done 50% minus 48.61%. Doesn't matter. I get the same answer. So it's going to be 0.0139, or in percentage format, 1.39. Again, you just move your decimal over 2 places to the right. Okay, so 1.39 is this area here. Now, it's not drawn to scale, but if I drew it to scale, you'd have a hard time seeing it. Okay, so that wasn't too bad, I hope. Let's look at this one. Now, you have to make sure you read very carefully. Find the area below 2.2. So again, draw the z-score distribution, and then put in the z-score. So in this case, it's 2.2. Shade in what you're looking for. That would be the next step. Now, here's a mistake I see people making often. They'll shade in here from 2.2 to 0. They shade this in. And they say, well, that's below 2.2. And well, it's below 2.2, but why did you stop at 0? I didn't say stop at 0. All right, so if I say below 2.2, I mean everything below 2.2 to negative infinity. All right, so again, make sure you read the question very carefully. So this area, we've already figured out, right? From 0 to 2.2, we looked it up in the z-score table, and we learned it was 48.61. And we already know this, right? We know that if we're asking for the area for exactly half the distribution, that's 50%. So to find the combined area, you just have to do 50% plus 48.61%, and that gives 98.61%. Or in decimal format, 0.9861. Now this is a special number. Why? Because it's the area that is at and below a certain score. Remember what that is? It's a percentile. So we have just calculated a percentile. We had to know the z-score, which came from a raw score, right? Let's say that this was Troy's height, and let's say he's, I don't know, 15 years old, and he's 5'10". All right, I don't know that he was 5'10" when he was 15, but he was pretty tall. All right, so 5'10" at 15, we would have converted that score, that raw score, to a z-score. And let's just say it was 2.2, let's just say, for argument's sake. Once we know his z-score, then we can use a z-score table and figure out the area below it. And in this case, we figured out it was 98.61%, so that's his percentile. And that's how percentiles work. Right, let's do this example together. So here we're looking for the area below a z-score of negative 2.2. So again, draw the normal distribution, shade in the area you're looking for. I know it seems really simple, but you know what? I can't tell you how many times in class I have made a mistake because I don't draw it out and I get kind of cocky and it's like, I know this, right? And I make a mistake. And it's because I skipped something really simple that would have laid it out in front of me and safeguarded against making stupid mistakes. Well, not stupid, but silly mistakes, okay? So we're looking for the area below negative 2.2, so we're looking for this area. Now, if we went back to the z-score table, you would see that there are no negative z-scores, right? And I don't care what textbook you pick up, which statistics textbook, you will not see a z-score that has negatives. And there's a very good reason for that. And that's because if you know what's true on the positive side, you know what's true on the negative side because they're mirror images of each other. So if I'm asking for that area, isn't that the same? Like flip it around, just switch these two halves around. That would be the same thing as looking for the area above 2.2 on this side. So, and we've already figured that out a few slides ago, right? Do you remember we looked up 2.2 and it gave us this area? And then once we knew this area, we were able to find this one, the shaded one. So finding the area below negative 2.2 is the same thing as finding the area above 2.2. Okay, so you look up 2.2, don't look up negative, it's not there. You look up 2.2 in the table, and remember it's going to give you the area between the z-score and 0. So when you look this up, it's going to give you this area. And to find this area, the shaded area, you just have to reason. This whole area is 50%. So if I subtract this white part here, I'm left with the shaded part. And so we did that, and that was 1.39%. Also, we could express this in decimal. We'd have to move our decimal 2 places to the right, and it would give us 0.0139. All right, that's in decimal format. This is also a percentile because we are looking at the percentage of scores at and below, right? At and below this z-score, so that's a percentile. Now, remember that areas and probabilities, area is the same thing as probability. When we talk about area under the curve, that's the probability of being in this area. So areas and probabilities can never be negative, and they cannot be greater than 100%. So, you might say, what's the probability that I'm going to die one day? it's 100%. Unless the laws of physics change, laws of nature change, it's a 100% probability that we're all going to die someday. Now, it makes no sense to say there's 1,000% probability that you're going to die. Okay? It's like 100% means with certainty. There's no doubt you will die. So it doesn't make sense to say 200%, 300%, 400%. Once you're dead, you're dead. Okay? So I know we'd like to say that, but in reality, these probabilities cannot be greater than 100%. Right, now this would be considered the most difficult question that you could ever get on these Z-scores. And if you can do this, you can do any Z-score question. All right, so this is a question where we're asking for the area between two scores. All right, so in this case, I'm asking between 2 and 2.5. Now note that whatever area is between 2 and 2.5, that would be the same as saying what's the area between -2 and -2.5. It would just be over on this side, but the area would be the same. Okay, so we want this. So we're going to have to look up two Z-scores, right? Doesn't really matter which one you look up first. I'll look up the larger one just because. I think you'll understand why it makes more sense maybe to look up this one first, but it can be done either way. So when I look up 2.5 in the Z-score table, it's going to give me the area between my Z-score and 0. Remember that? Z-score and 0. So in other words, it's giving me this area here plus this area. This combined area is the area between 0 and 2.25. So if you go and look in the table, you'll see that that area, when you find where that intersects, right? I showed you how to use the table. You get 49.38. Okay, so 49 or 0.4938 if you're using decimal format. Percentage format, it would be 49.38%, which is 0.4938 in decimals. Okay, that's this larger section. Now if you look up 2 in the Z-score table, it's going to give you the area between 0 and 2. So in other words, it's this white area. All right, so we write it down. Between 0 and 2, it's this area. But we don't want this area, and we don't want the combined area, do we? We want to find just this shaded area. So if we took the larger area, which is this, took all this, and subtracted this, then we would get the shaded area. So this big chunk here was the 49.38. This smaller chunk is the 47.72. So you take the big chunk minus the small chunk. Big chunk minus small chunk gives you the shaded area, which turns out to be 0.0166 in decimal format. To get the percentages, again, move it over 2 decimal places to the right, and you get 1.66%. So what is the probability of falling here? Okay. This is a visual to help you. You take the larger area, which is the one between 0 and 2.5, minus the smaller area gives you what's left. So the area that's left is between 2 and 2.5. All right. Now, we can understand why people would want to know percentiles. When you take a standardized test like the ACT, SAT, GRE, MCAT, they're all giving you scores in percentiles. And that tells you how you did relative to the other people who took the test. Ideally, you want to be above 50%. If you're in the 50th percentile, that means you were right at average. But if you're in the 60, 70, 80th percentile, it means you're doing better and better and better, right? More and more people are getting your score or lower. You don't want to be below 50th percentile. That means you're below average, at least on that particular part of the test. But what about this? Why would we ever want to know what is the probability that somebody would score, above a certain Z score or between two Z scores. Well, there's always a time, I guess, for everything. I could look at the distribution of scores on a test. And let's say a student comes up to me and says, I don't know, I was sick, sorry, I couldn't take the test. And, would you please let me take it now? And I say, sure, you can take the test. And let's say that this student, all semester long, was barely a C student. And all of a sudden, they're getting like 99% on the most difficult test of the semester. I could take everybody's raw score, convert it to a Z, take this student's raw score, convert to a Z, and see what the probability is that somebody could get that score or higher. And if it's like 0.000001%, then I'm like, maybe that student was a little perhaps dishonest. Now that in and of itself is not foolproof as far as I wouldn't go up to a person based on that alone and say you cheated, but there's a suspicion level there, okay? Because the probability of getting a score that high is so low. Getting between two scores, it could be that maybe these standardized scores, these Z scores, come from cholesterol levels. And maybe we're looking at what is the probability that somebody would have a cholesterol level in this range. Maybe it has something to do with people in this range have elevated levels of COVID-19 risks or something. I mean, so if you're trying to figure out what percentage of the population might be in this range, which would put them at the highest risk for COVID complications, I could see that being a reason why you would want to know this area. All right. So by far, percentiles are the most commonly used, reasons for calculating areas under the curve. But certainly there's, situations where you might want to know, what percentage of the population would be in, this upper end. Maybe that's the greatest risk level for COVID. Or maybe there's some bizarre thing going on, and this is the most riskiest, range to be in. You'd want to know what percentage of the population is in this risky range. All right.